Hello. Yes, we welcome you back to this channel, PSSB, and it's me, Richard. Okay. Today we are looking at this question. It's coming from vertical projection. Okay, let us analyze it. It says an object is released from point P above the ground. It travels the last 30 meters QR in 1.5 seconds before hitting the ground. And the question comes, calculate 5.1.1, the magnitude of the velocity of the object at point Q. Okay. So when you look at this scenario, this is what we notice. We notice that the first part of the journey, PQ, is not given. We don't know anything about it. We only know only one thing. What is it? Dropped means initial velocity or released. So remember, we start from known. So let us use this part of the journey QR. Okay. When you look at this journey, what do we know? Okay. First of all, we know displacement covered, delta x, which is 30 meters. Okay. What else do we know? We know the time taken, and the time is 1.5 seconds. We also know g. The object is going downwards, so g is positive and is 9.8 meters per second squared. What else do we have? Now we are looking at the velocity. So when you look at this journey from Q to R, Q happens to be our initial point. So the velocity at Q, which we are looking for, is going to be the initial velocity. Okay. So what do we do next? So when you look at the data we are having, where we are having delta x, displacement, time, and this, next is to choose the equation. So what's the choice of equation which suits this data? It's going to be the third equation, which says delta x is equal to vi delta t plus a half a delta t squared. Okay, on substitution, what do we have? Okay, so this is what we have after substitution. And when you analyze the substitution, our only unknown is vi, which you can only get through rearrangement and computer substitute and pressing the calculator. So let us look at that. So when you rearrange, this is what we get. We get our initial velocity, or the velocity at Q, as 12.65 meters per second. Okay. So let us look at the next question. The question reads, that calculate the time for the entire journey of the object from P to R. So what is the time taken for the object flow from P to R? So to approach this question, there's something we have to know. We know the time the object took to move from Q to R, and it was 1.5 seconds. Okay. So what is our approach on this one? We are going to assess this side, the upper side, from P to Q, and you get that delta T. Now when we get this delta T and we add it to 1.5, we will be getting the time for the entire journey. So let us look at the information for that journey. What do we know? We said the object was released, so we know VI, and VI is 0 meters per second. Okay, we are talking about this journey up to Q. We calculated the velocity at Q, and that one is going to be our final velocity, which is 12.65 meters per second. What else do we know? We know G, the acceleration due to gravity, and the body is going downward, so it's positive. It's 9.8 meters per second squared. What else do we know? We look for our unknown. Our unknown is delta T. So that's it. So with that, what is next? Choice of the equation. What equation suits this data? So it happens to be the first equation, which says VF is equal to VI plus A delta T. On substitution, we have this one as 12.65. You have this one as 0. You have this one as 9.8 times delta T. And when you look at that equation, the only unknown is delta T, which we can find. Let's find out what it is. So that is that. We have just got our delta T, which represents P to Q, as 1.29 seconds. What do we do? Now we find the sum of the two. So in other words, our delta T, which is the delta T, which is PR, is equal to delta T, which is PQ plus delta T, which is QR. So what do we get here? This one we have just found out it is 1.29, and this one we know it as 1.5. What you get out of that will be the total time for the entire motion. Let's find out what it is. So that is that. So the time for the entire journey from P to R is 2.79 seconds. Okay, so that's that. I would appreciate if you use S for second as the unit. Yeah, so that is that. So with that, we are going to cut the video here. We appreciate your time. Don't forget the channel is PSSB. please, we urge you to subscribe. And if you have already subscribed, we would urge you to click the like button. We would appreciate that. See you next time. Bye bye.